Good afternoon, everybody. My name is Parshuraman Narsimhan, and this session is going to be about IndexedDB, the storage in the browser. Through this session, I will be trying to cover the HTML5 standard called IndexedDB that lets you store data in your browser. Before we get into the entire problem, let's try to understand the space a little bit better. The first question that almost all of us ask is, should we really be online to use rich internet applications? Well, with the HTML5 standards coming in, this is no longer true. There are different classes of applications that can function as good as the native applications when you're offline. Typical examples include intermittently connected applications like your calendar or your email clients. They also include disconnected applications like to-do list and sticky notes, and even applications that require to cache a lot of data on the client side. Typically things like user profile and shopping catalogs can benefit from the offline capabilities of web browsers. As I mentioned here, the IndexedDB standards complements the app cache standards very well. With IndexedDB and app cache together, developers can now build offline applications very easily. Before we get into what IndexedDB is, let's look at the different ways in which you can really build an offline web application today. IE9 has released very recently, and IE9 has a lot of HTML5 standards coming in. And if you notice today, most modern web browsers support cookies. They also support local storage or session storage, and these are very two common ways in which data can be stored on the user's machine. Unfortunately, all the techniques mentioned on the slide that you see have limitations. Cookies, for example, have a storage size limitation. There's only a certain amount of data that you can store. Reading back data from the cookies is also not very easy. Web developers will have to manually concatenate or substring data to understand what the cookie value is. The second alternative is local and session storage. Local and session storage are also good and were intended for storing data locally. Unfortunately, there are no easy ways to iterate over the data that you have stored. Additionally, you don't have the power or capabilities of finding data in ranges, indexing them, or sorting them. One very interesting standard, or a competing standard I should say, is the Web SQL database, something that originated originally from the Gears project. This is a complementary standard, and the idea of Web SQL database was to try writing SQL kind of constructs inside JavaScript. Unfortunately, this is not JavaScript itself, and even the SQL language that was written was not standardized. That was one reason that most browser vendors like Mozilla and Microsoft have stepped away from the Web SQL database standard and have gone or acknowledged the standard called IndexedDB. The slide that you see here is a quick introduction of what IndexedDB is and the capabilities of this standard. So, as I was saying, IndexedDB is a persistent storage in the browser. It lets you store data on the user's machine. You can read and write data very easily that way. IndexedDB is a part of the HTML5 set of specifications. This is one standard that's still in its draft mode, and the editor comments are still on. To give you a quick example of what IndexedDB looks like, in short, IndexedDB is just an object store. It is not relational, and it gives you the capabilities to put and get objects. Additionally, it also gives you the power to iterate over these objects in any sorting format that you want. You can create indexes over properties and pick and choose properties that you would like. The IndexedDB API itself comes in two flavors. The first one is synchronous and the second one is asynchronous. The asynchronous format is something that's very similar to the AJAX pattern that most JavaScript developers are familiar with. The asynchronous pattern is available on top of the window.global object, and this pattern is the one that's most commonly used to ensure that the user interface is not frozen. In the asynchronous pattern, you effectively make a call to the indexed database API and the call returns immediately. Once the database operation is complete, you will get a callback, and in the callback, you will get to know the results of your operations. This is in contrast with the synchronous flavor of the APIs, where whenever you make a call to the IndexedDB APIs, the call is blocking and will return only after the database API is complete. The synchronous APIs are available over web workers, and hence they do not freeze the user interface. Before we look at some code, I wanted to take you through a bunch of concepts that will make it easy for you to understand IndexedDB. So the first one is how do you install and what are the prerequisites. So let's look at the browsers that allow the implementation of IndexedDB today. Internet Explorer 8 and Internet Explorer 9 do not have a native implementation of IndexedDB, given that IndexedDB is still not a finalized standard. That is the reason why Microsoft has come up with this website called HTML5 Labs, where the new and upcoming features of HTML5 standards are typically prototyped. What you see here in this website are links to download the IndexedDB standards. Another standard on this website is the WebSockets, which is at a similar state. Apart from Internet Explorer, Firefox 4 and Chrome also support IndexedDB, however, in their vendor prefix format. So those are the prerequisites, those are the browsers that support IndexedDB, and installing IndexedDB for Internet Explorer 8 or IE9 are very simple. I have Internet Explorer 9 on my machine, and I have completed downloading the package here. You see a download link at the HTML5 Labs. Once you download IndexedDB, you get a zip file that you can unzip, and there is a README that tells you how to basically install IndexedDB. The entire package is available as a very simple ActiveX object, and this command that I have selected here is the way in which you install IndexedDB. So I open my command prompt in the administrator mode, and I have just completed running regserver32 on the IndexedDB DLL. Once I hit enter, I got a prompt saying that this DLL was successfully installed. That pretty much means that I've been able to install the prototype of IndexedDB for IE9. Once we have the prototype ready, we can get started with the examples. Let me switch back to the slides and quickly show you the different concepts and then walk you through examples. So, a very interesting concept in the way IndexedDB APIs are structured is the concept of requests. Whenever you make an IndexedDB API call, you always make a request. Once the call is complete, the request object's onSuccess or onError method is called. I will show you more of requests as we look at the different APIs. So the first thing that we know when we encounter IndexedDB is the concept of a database. That's the object that stores all your data. This typically would be a simple database file, and you effectively connect to this database to get or put objects. Once you're connected to a database, you have the concept of object store. Before we get onto the object store, let me show you some code on how you effectively would connect on the object store. I've switched back to Internet Explorer 9, and this is a website that has the paid code in where I can demonstrate how it works. So as I said, IndexedDB is already installed here, and I'm showing you the code for how to run it. We may need to do a couple of things before we get to our examples, because this is just a prototype. The first thing is that we will have to initialize the IndexedDB object using this line at the top. We need to do this only for the prototype because, as I said, the package that you downloaded was an ActiveX object. Once that is done, let's look at how the Open Database call works. I've clicked on the Open Database call, and this is how the Open Database call looks like. It's on the second line of the example, where I say window.indexedb.open and provide the name of the database and a simple description. If the database does not exist, it is automatically created. If the database exists, the existing database is opened. This is one place where I'd also like to reiterate the concept of requests. You must have noticed that the return value of the open call is a request. What I do here is, on success of the request, I run a function which effectively says that the database is open. On error, I say that there was an error and I cannot proceed further. So let me quickly run the prerequisites first. I click on the run button here at the top to run the prerequisites, and then I click on open database and run it. If you notice, the trying to open database message is printed on the console at the bottom, and then once the database has opened, the on success event is fired and the database opened message is printed second. I've also tried to print what the DB object is, and here is what it is. Let me go back to the slide and tell you what an object store now is, because we now know that we can open the database and do actions on it. So the object store is your very basic place where you can put and get objects. It's synonymous to tables in the relational world, and objects typically are a key and a value pair. The value can be any JavaScript object, and that is converted into its serialized form using the structure cloning algorithm standard. The key can be any string, integer, float, or date. Let me go back to the examples to show you how I create object stores, and how I open the object stores. So here's the example where I create object store. So one thing to notice here is a concept of transactions. Since IndexedDB is a database in itself, it helps you in providing isolation between requests by providing transactions. There are three types of transactions: a read write, and version change. They have the very same meaning as in the relational world, where a read write transaction lets you read and write to the database. A read is a read only transaction, and let me explain to you in detail what a version change means. A version change transaction is a special kind of transaction that waits for all the other transactions on the database to complete and only then starts running. Certain operations like creating object stores or creating indexes can only be run in the set transaction method. This ensures that while you are reading data from your database, the schema is not changed suddenly. So what I'm doing in this part of the code is I'm trying to set the version of the database to a next version by doing this +1. Once the set version transaction is complete, I try to create an object. This ensures that there are no other transactions and there are no other browser tabs trying to read from this database. Once I have gotten into the transaction, I say create object, and I specify the name of the object store that I want. In this case, inside the database book store, I am trying to create an object called book list. The second argument that you see here is the primary key that I want to use. In this case, I plan to call it the ID. The last argument that you see is a Boolean argument that tells the database whether it has to auto increment the primary key or not. In this case, I have chosen to auto increment it. Let me also show you how the open object store works. So this code may look a little bit complicated, but it's only because it tries to include and explain transactions. So what I do here is that I try to create a new transaction using the db.transaction method. This method takes two arguments. The first argument is the name of the object store around which this transaction should run. The last number here says whether it should be read write, or version change. And when I say 0, it effectively means this is a read write transaction. Notice that this is different from the set version transaction, and this read write transaction can definitely run against other transactions. I have also said that when the transaction is complete, I just need to print a message, or if the transaction is aborted, I print another message. Once that is done, I try to get the object store using the transaction.objectStore method here. This effectively returns the book list object store with the read write transaction for me. You may have to notice here that the scope of the transaction, which is read, read-write, or version change, will be common for till the lifetime of the transaction. You cannot change the scope or the mode of the transaction in the middle of a transaction. Now that we have the object store, let's try to put or get data. So there I've told you about what transactions are, what are the read, write and version change transactions are. Before we get into cursors, let's just try to put some data into the database. The save data method here that you see is the one responsible for putting data. The code that I have selected tries to put a simple book inside my database. It effectively has a book name, an author, a price, and a rating. You must have noticed that I did not specify the primary key, the ID, in this. I'm sure you would have guessed by now that since ID is auto-incrementing, I don't have to specify it here. Also, across the examples, you may notice this console helper.waitFor function that encapsulates all our database objects. This is only a helper method that waits till the object store is defined to do the actual operations. In real production code, you may not need this because the selected block of code will actually sit inside the place where your object store has been returned. Writing to the data store is very simple. I have the object store which I returned using a transaction, and to that I call the add method with the data as my argument. The same concept of request applies here also, where the request.onSuccess just saves that my data has been written, and the request.onError says that there was some issue that the data could not be written and I will have to abort this transaction. Let me try running this operation. I would load all the prerequisites and click on run. And here it says that the ID 6 and the ID 7 have been saved. This is because I hit run earlier and the object store was not defined. So what I have now is that I have been able to write 2 objects to the database. Once I have written objects to the database, let me try to read them. Reading is very simple if I know the ID. All I would have to do is take a look at the get method. So here in my case, the object ID was 7, which was the last object ID that I returned. I can click on run and it should be able to give me the last object that I ran. If I click on this object here in the results, you would notice that the ID was 7 and this was the object that I had written. Similarly, I can also modify data using the put method. This is very similar to the add method and uses the same arguments. Deleting data is also very simple. I can delete data based on the object ID here, which is nothing more than the ID or the primary key. In this case, when I hit run, it will try to delete the ID which has a number 7. You would have noticed that this record here has been deleted. It's easy to work with these single objects, and I'm sure you're thinking that this is what we used to do in the local or the session storage. Let's get into powerful concepts like the cursors and indexes that help us do more operations on the overall database. So what is a cursor? A cursor lets me enumerate over objects using the continue method. This is just like the enumerable class or an iterator, if you may, on the entire object store. The best thing about cursors is that I can have ranges of objects returned to me by the cursor, and these are done using the ranged cursors methods. Let me show you how cursors look like. Going back to my code here, and I've just clicked on the open cursor method. Let me clear the console, and let's take a look at how the open cursor method looks like. The open cursor method is very simple. All I have to do here is on the object store, I open a cursor. You must remember that the object store that we have open here is the very same object store that we opened using the open transaction method here. For your benefit, let me just show you the code once more. So I clicked on the open object stores example, and I had gotten the object store on this line. Notice that it's on the same transaction, which is the read-write transaction. So it is this very object store that I am planning to reuse in my cursor methods. Let me go back to the cursors again now. I click on cursor and see the open cursor method. The cursor always returns a cursor object to me, and I could use this to iterate over the objects. For now, let me just try to run this and get the cursor. Here I get a message saying cursor created. This is the cursor for me. Let me show you that how to view all the objects once I have the cursor. I click on get all objects example, and here's a simple example that does it. I have this function called iterate on cursor that is called by itself, and all that it does is calls the cursor.move method. The cursor.move method returns, if it is successful, calls the onSuccess method. And what I do here is try to print the key and the value. This is good as long as the cursor has some value returned in E as a part of the move request cursor.move operation call. If the E.result is not returned, I say that I have reached the end of the cursor and commit the transaction so that I can continue with what if the other tabs are using the database, they can continue with their operations. I can click on run, and it displays all the elements that I had added. During the course of this session, I had added 2 elements, 6 with ID 6 and 7. You must also have noticed that I had deleted the element with ID 7, and hence it no longer shows up here. I can click on these individual objects to see what the content is in this case. What you're seeing here is the number 6, which corresponds to the key, and the value which corresponds to this object. The value of I, which is the iterator, is also printed, effectively telling me which numbered object is it. The advantage of cursors is that not only can I iterate over the objects, I can also try to update them. If you notice, in the get object method, I had this JavaScript call on the cursor object called move. In case of update, the entire operation looks very similar with just one exception. There is a new update operation on the cursor which I can perform to update individual elements. What I am doing here is very similar to what I did in the previous example. The only difference being I try to open a new request on the cursor.object, which is called the update request, and once the object is updated or once it's not updated, I call these callback functions. Let me clear the console and try running it here. I did have to load the prerequisites. Click on load prerequisites and try running here. And here what it says is that all the objects have completed running, but unfortunately for me, the value was undefined. Let me try to open up the list of objects again. Try loading all the prerequisites again and hit run. And what I see here is that this new cursor property was created as a result of my previous update method. So if you notice the update method, I tried to create a new cursor property and assigned it a random value. That random value was appended and my entire object had changed. Iterating over all the objects and removing them is also very simple. Instead of the update method, I just would have to call the remove method, and that specific object will be removed. If I was to run this example, I would iterate through all the objects listed here and would be removing them one after the other. Let me not do that right now because I would like to show you what indexes are. So just to recap on what we have seen till now, we have tried to understand what a database is, what an object store is. An object store basically is a place to get input values. I told you what transactions are. We were talking about read, write and version change transactions. And we were also looking at what cursors are. I showed you how we can use cursors to iterate over objects, to try updating them one after the other or even removing them. The one final concept that I would like to show you here in this case would be indexes. Indexes are nothing more than object stores on a non-primary key. If you notice in the previous examples, the cursor here always iterates on the property that is indexed. Let me go back to the examples and show you how it works. So as I was saying, when I tried to print the values in the cursor, the key was always the primary key. However, there could be chances where I would like to sort it on the price or on the rating and things like that. And that is when I try to create an index. These are very similar to the database indexes in the relational world. So let me see if there are indexes already on the database. I can see that using the object store.index names. Clear the console and hit run. Right now it says that there are no indexes. So let me try to create one. I click on create index, and if you notice, the name of the index here is price index. The column on which this index should be created is price, and this need not be a unique index. You may have to pardon me when I say column, because the object stores that we are using, the objects that we are storing need not have the exact same columns. They effectively are simple JavaScript objects, and this property called price may or may not exist for certain objects. I click on run, and I should have a new index created. I click on this indexes again, and I should be able to see the new index that was created. Yes, it is here. It's called a price index. Once I have created an index, I can open an index and get a cursor on the index, which lets me iterate in a very similar fashion that I saw earlier. Opening an index is very simple. Just like I did open cursor on the object store, I can do an object store.index and give the name of the column that I would want to iterate on. The onSuccess and the onError methods are very similar. Before we move on, there was just one more additional information that I wanted to give here. Notice that in this case, I'm not trying to set a version, or I'm not talking about transaction. This, however, has changed in the latest version of the IndexedDB specifications. The latest IndexedDB specifications, which is available here, says that the IndexedDB APIs like create index or create object store can only run in the set version context. For now, let's assume that that part of the change specification is taken care of, and let's move on with our examples. So I click on open index, I load all the requisites, and I click on run. So here it says that the index is opened. The open index call, as I told you, is very simple. It says that the index is open, and now I can there are two types of cursors that I can get on the opened index. The first one is a key cursor, and the second one is an object cursor. Let me explain each of them in detail. If you notice here, what I have done here is I've called the open key cursor method on the index that I just opened. And once that cursor is open, the cursor iterator function is the very same function that you saw in the getAllObjects examples under cursors. I am trying to print the key and the value here. And what you're seeing is these values here are effectively sorted based on the price. So you get 63, 510, and 547 in the sorted order. So hence, it's not sorted on the primary key. It's effectively sorted on the price here. The object cursor is a little bit different. So when I just say index.open cursor and try to run this example, what it tries to do here is it tries to get the key and the value. However, the value here is the primary key instead of the object itself as in the previous case. So let me just run the previous example again for your reference. So in this case, the key was the primary key and the object was the object itself. Here, however, it is indexed on price, and the value of the object, which is this variable here, is the primary key of the object. You may be using this if you just want to retrieve the primary key and see how it was all sorted, and you do not want to retrieve the entire object if it is a very heavy object. So this is the difference between the key cursor and the object cursor. The final call that I would like to show you is about the remove index object. The remove index itself is a very simple call where you say remove index and you give in the price index. And once you run this, the index should be removed. Right now, this implementation does not support the remove index property. However, remove index is a part of the W3C specification on IndexedDB and can also only be done on the set version change. This final method here simply sets the version that we have been using across transactions and various other constructs. So I click on run, and the new version of the database is set. Let me go back to the presentations and do a quick recap of the concepts that we have seen. So till now we saw what cursors were. We also noticed that indexes can help you get cursors and can sort database objects on non-primary keys of the object. Through the session, we also were able to see different snippets of code, and I would be sharing this URL at the end of the session, but in this URL are listed all the different examples that you can use to try out IndexedDB examples. Here are the resources that I have used for the example. The first link here is a link to the IndexedDB specification. The second link here is a link to a tutorial article on how to start using IndexedDB in your applications. And the final link that you see is a link to the examples that I was showing you. This is the final link here. That's all I had for the IndexedDB session here. I would like to thank you for your time in taking time to attend this session, and would love to hear your questions or feedback about this standard at the email given below. Thank you.